Hello, everyone, and welcome to English Speaking Gym. I am really happy you are here with me today. Today, we are going to practice our English while learning something interesting about science. Our topic today is a simple question that many people have asked. Why does ice float on water? Put on your headphones. Relax your shoulders. Take a slow breath, and let's begin shadowing together. When I first thought about this question, it seemed very simple. Ice floats in a glass of water. Ice floats in lakes. Ice floats in the ocean. We see it all the time. But when I started thinking more carefully, I realized something surprising. Most solid materials actually sink in their own liquid. For example, solid metal sinks in melted metal. Solid wax sinks in melted wax. So why is water different? Why does solid water float on liquid water? To answer this question, I need to talk about a concept called density. Density describes how much matter exists in a certain amount of space. In simple words, density tells us how heavy something is compared to its size. Objects with higher density are heavier for their size. Objects with lower density are lighter for their size. When something is placed in water, its density determines whether it sinks or floats. If the object is denser than water, it sinks. If the object is less dense than water, it floats. For example, a rock sinks because it is denser than water. A piece of wood floats because it is less dense than water. Now here is the surprising part. Solid ice is actually less dense than liquid water. That means ice weighs slightly less than the same amount of liquid water. Because it is less dense, it floats. This is unusual because most substances become denser when they freeze. Water behaves differently. To understand why this happens, I need to talk about molecules. Water is made of tiny particles called molecules. Each water molecule contains 2 hydrogen atoms and 1 oxygen atom. These molecules are always moving. When water is warm, the molecules move very quickly. As the temperature drops, the molecules move more slowly. When water begins to freeze, something special happens. The molecules start forming a structured pattern. They connect together in a crystal structure. This structure looks a bit like a repeating hexagon pattern. Because of this arrangement, the molecules spread slightly farther apart. This means that frozen water takes up more space than liquid water. Even though the amount of matter stays the same, the volume increases. When volume increases but mass stays the same, density decreases. This is why ice becomes less dense than water. And that is why ice floats. We can actually observe this effect in everyday life. For example, when I fill an ice cube tray with water and place it in the freezer, the ice cubes expand slightly. Sometimes ice even pushes upward in the tray. This happens because the frozen water occupies more space than the liquid water did before freezing. Another example happens in nature. When water freezes in small cracks inside rocks, the ice expands. This expansion can slowly break the rock apart. Over time, this process helps shape mountains and landscapes. It is one of the reasons why rocks slowly crack and crumble in cold climates. But the fact that ice floats is not only interesting, it is also extremely important for life on Earth. Imagine what would happen if ice sank instead of floating. In winter, lakes and rivers would begin freezing from the bottom upward. Eventually, the entire body of water could freeze solid. This would be very dangerous for fish and other living organisms. Instead, something different happens. When winter arrives, the surface of a lake freezes first. The ice floats on. When I think about ice floating, I realize how a small scientific detail can have huge consequences. It affects rivers, lakes, oceans, weather, ecosystems, and even global climate. Sometimes the simplest everyday observations lead to the most fascinating scientific explanations. Let me summarize the main idea clearly. Ice floats because it is less dense than liquid water. This happens because water molecules form an open crystal structure when they freeze. This structure spreads the molecules farther apart. As a result, frozen water occupies more space than liquid water. The lower density allows ice to float. Understanding this simple property helps scientists explain many natural processes. It also reminds me how unique water is compared to other substances. Water may look simple, but its behavior is surprisingly complex and essential for life. Great shadowing so far. Now let's practice some useful vocabulary. I will say each word slowly, I will explain the meaning. Then I will give an example sentence. Please repeat each word with me. Density. The amount of matter in a certain space. Example. Ice floats because its density is lower than water. Molecule. A tiny particle made of atoms. Example. Water molecules move more slowly as the temperature decreases. Crystal structure. An organized pattern of molecules in a solid. Example. Ice forms a crystal structure when water freezes. Freeze. To change from liquid to solid because of cold temperature. Example. Water begins to freeze at 0 degrees Celsius. Expand. To increase in size or volume. Example. Water expands slightly when it turns into ice. Iceberg. A large piece of floating ice in the ocean. Example. Most of an iceberg remains underwater. Now let's practice some useful power phrases that you can use in everyday English conversations.
It looks simple, but there is a deeper reason. Example. It looks simple, but there is a deeper reason behind it. It looks simple, but there is a deeper reason we need to understand. The difference may seem small, but it matters. Example. The difference may seem small, but it matters in the long run. The difference may seem small, but it matters more than you think. This is what makes it unique. Example. This is what makes it unique compared to other systems. This is what makes it unique and important. A small change can have a big impact. Example. A small change can have a big impact over time. A small change can have a big impact on the outcome. Once you understand this, everything becomes clear.